Welcome to another video by the Security Buddy. In this video, we will discuss what the R-squared code is and how to interpret the value of the R-squared code. Let's say x is a continuous independent random variable that denotes the height of people and it takes the following values. Let's also assume that y is a dependent random variable that denotes the corresponding weights of people and y takes the following values. Now, we use linear regression to calculate the fitted values of y. Let's denote the calculated or fitted values of y as y hat. So, how well did the model perform? To know that, we can calculate the R-squared code of the model. If for a particular value of x, let's say xi, the observed value or the expected value of y is yi and the fitted value or the calculated value of y is yi hat, then we define the error or residual as ei is equal to yi minus yi hat. And we define the residual sum of squares or sum of squared error as SSE is equal to summation from I is equal to 1 to n yi minus yi hat whole square. We also define the total sum of squares as summation from I is equal to 1 to n yi minus y bar whole square, where y bar is equal to summation from I is equal to 1 to n yi by n. In other words, if we take the difference between the observed values and the calculated values of y, square them and sum them up, we get the sum of squared errors or SSE. And if we take the difference between the observed value and the mean value of y, square them and sum them up, we get the total sum of squares or TSS. R squared is defined as 1 minus SSE by TSS. When a regression model always predicts the calculated values of y as the mean value of y, SSE becomes equal to TSS. In that case, R square is equal to 1 minus SSE by TSS is equal to 1 minus 1 is equal to 0. And when a regression model always predicts the calculated values of y as the observed values of y, then SSE becomes equal to 0. In that case, R square is equal to 1 minus SSE by TSS is equal to 1 minus 0 is equal to 1. Hence, we often expect the R square score to be closer to 1. But please note that R square actually represents how scattered the data points are around the fitted regression line. For example, in this graph, the data points or the observed values of y are represented with black points and the green line represents the regression line. We can see the data points are much scattered around the regression line. The R square score in this case is 0.80. On the other hand, in this graph, the data points represent in black color are less scattered around the green regression line. The R square score in this case is 0.98. And when the observed values fall exactly on the regression line, the R square score is 1. In practical scenarios, we do not get R square score to be 1. Usually, an R square score closer to 1 is good. But please note that a high R square score does not always mean a model is good, or a low R square score does not always mean the model is bad. A high R-square score may also mean that the model is overfitted. So, we often use adjusted R-square score or predicted R-square score to address the problem. What are the adjusted R-square score and the predicted R-square score? We will discuss them in a separate video. The link will be provided in the description. I hope this helps. Interested viewers who want to know more, please refer to the playlist Linear Regression or Statistics for Machine Learning, or visit the website of the Security Buddy. The relevant links are provided in the description. You may also want to subscribe to us and get notifications on recent videos.